Let's look at section 4.4, the example problems. Example 1, evaluate each power without using a calculator. Well, what we're going to do is we are going to turn these into radicals so they kind of make more sense in our head, and it gives us some practice. So 1,000 to the power of 1/3 is equal to the cube root of 1,000. And the cube root of 1,000, you should know, is equal to 10. If you have your list of perfect cubes and perfect squares around, you'll be able to see that the cube root of 1,000 is equal to 10. 0.25 to the power of 1/2. Well, this is equal to the square root of 0.25. Now, we know the square root of 25 is 5. The square root of 0.25, what is that? Well, let's take 0.25, which is 25 hundredths, and turn it into a fraction. So it's the square root of 25 over 100. And that's going to be equal to the square root of 25 over the square root of 100, which will equal to 5 over 10, which equals as a decimal 0.5. Now, here I'm going to make a mention of this because this is quite interesting. Let's look at the square root of 25. So I'm going to do this just as an aside, and I'm going to erase it in just a moment. The square root of 25 is equal to 5. The square root of 2.5 is equal to some weird irrational decimal number. It is irrational. The square root of 0.25 is equal to 0.5. The square root of 250 is again equal to some irrational number. But the square root of 2500 is equal to 50. So you can see if you take one of our original perfect squares and you multiply it by 100, you get another perfect square where the answer is multiplied by 10. Likewise, if you divide it by 100, if you divide our perfect square by 100, so our perfect square is 25, we divide it by 100 to get 0.25, then our answer for the square root is 5 divided by 10, 0.5. It's just an interesting pattern. If you do enough square roots, you'll pick it up. All right, let's take a look at the next one. Negative 8 to the power of 1/3. This is equal to the cube root of negative 8. Now, the cube root of 8 is 2. Negative numbers also have cube roots. And the cube root of negative 8 is just negative 2. Negative numbers do not have square roots. But negative numbers do have cube roots, and the cube root of a negative number is another negative number. 16 over 81 to the power of 1/2. Power of 1/2 means square root, so we square root 16 over 81, which is equal to the square root of 16 over the square root of 81, which is equal to 4 over 9. Example number 2. Evaluate. Again, we're going to do this as much as we can without a calculator by converting it into a radical form that will help us make sense. All right, so the denominator tells me that I'm going to square root it. So I'm going to have the square root of 0.01 raised to the power of 3. The numerator tells me that I'm going to raise it. I'm just going through this. All these steps that we did up here, I'm just shortcutting it from the start to the end. I guess it's more like this one here. 6, I'm shortcutting it straight to the end, where our denominator tells us the index on the radical, And the numerator is the power that we will raise that to. So this gives us the square root of 0.01. What is the square root of 0.01? Well, it's 0.1 to the power of 3. Then we do 0.1 times 0.1 times 0.1, and we get 0.001. That's our final answer. Okay, let's shortcut this. The denominator tells us the index of the radical. The cube root of negative 27 raised to the power of 4. The numerator tells us the power at the end. So the cube root of negative 27, well, we know the cube root of 27 is 3, so the cube root of negative 27 must be negative 3 to the power of 4. And negative 3 to the power of 4 is negative 3 times negative 3 times negative 3 times negative 3. It's equal to plus 81. You can do that on your calculator, or you can do that in your head, because 3 times 3 is 9, times 3 is 27, times 3 is 81. And an even number of negatives multiplied together will be a positive. 81 to the power of 3 over 4. The 4 is going to be the index on our root, on our radical. So the 4th root of 81 to the power of 3. The 4th root of 81 to the power of 3. Now the 4th root of 81, just take a look at our previous question up here. The 4th root of 81 is 3 to the power of 3, which will equal 27. All right, our next one, 0.75 to the power of 1.2. Well, this one's not a fraction, is it? Let's turn it into a fraction. So it is equal to 0.75 to the power of 12 divided by 10. Okay. Which is equal to 0.75 to the power of 6 over 5. Good so far. Now, our denominator is going to become the index of our radical, the 5th root of 0.75 to the power of 6. Now, there is no easy 5th root of 0.75. The 5th root of 0.75 is some irrational number that doesn't terminate or do anything else for us, so there's no real easy answer to this one. We're going to leave it at this point. Should be able to evaluate that on your calculator. Your calculator can do fractions in the exponent using the fraction button on your calculator. So however you use that ABC button, you can do 8 raised to the power, and then use the ABC button to figure out, to put in a fraction for your exponent. All right, let's take a look at example 3. Write 26 to the power of 2/5 in radical form in 2 different ways. All right, so first off, we know our denominator becomes the index of a radical, and the 2 is what we raise the power. So we can write this as the 5th root of 26 squared, with the squared on the outside. Right, this would be similar to writing it like this, 26 to the power of 1/5, all raised to the power of 2. But we can write it a different way. We could write it 26 to the power of 2 raised to the 1/5. In this case, we would get a different looking radical. We would get the 5th root of 26 to the power of 2. This time the exponent is part of our radicand. Whereas in our first one, the exponent was not in our radicand. So we can write it both ways by separating out the fractional exponent into this form or this form. All right, let's write these radicals in exponent form. So, right, we've been writing exponents in radical form. We should be able to go the other way. So let's look at the first one. Square root, that has an index of 2. So we are going to get 6 to the power of 5 raised to the power of 1/2, which will then equal 6 to the power of 5 over 2. And now it is in exponent form. Number 2, the fourth root of 19 to the power of 3. Notice now that we have parentheses, so we have to keep those parentheses around. So we're going to have 19 to the power of 1 over 4, right? The fourth root of 19 is 19 to the power of 1 over 4. We're going to raise that to the third power. Now we multiply our exponents together like our exponent law says, and we're going to get 19 to the power of 3 over 4. All right, you can take a fractional exponent, turn it into radical form. You can take a radical and turn it into a fractional exponent form. Example number 4. Use the formula b equals 0.01 m to the power of 2/3, where b is the brain mass and m is the body mass, to estimate the brain mass of each animal. So b stands for the brain mass given a certain animal's body mass. So basically means a bigger animal is going to have a bigger brain. All right, so a moose has a body mass of 512. That is our m. Body mass is m. So let's write out our formula. B is equal to 0.01 m to the power of 2/3. Now let's fill in our values that we know. 0.01, 512 to the power of 2/3. Now, you should be able to use your calculator and your fractional exponent buttons to do 512 to the power of 2/3 first. My calculator on my iPad doesn't really do fractional exponents very well, so I can rewrite this as b is equal to 0.01, the cube root of 512 squared. Now, the cube root of 512 is equal to 8.005. 001 times 8.01 squared. Now, I just kept the more precise decimal approximation in my calculator. I square it, and b is equal to 0.01 times 64.1, and b is equal to 0.64 kilograms. All right, so my calculator does not do fractional exponents very well, so I just converted my fractional exponent into a radical. All right, let's do the same thing with the cat. So b is equal to 0.01 m to the power of 2/3. B is equal to times 5 to the power of 2/3 times, now I'm going to write this a little bit different. I'm going to write this one the other way. This one's going to be the cube root of 5 squared. So b is going to be equal to 0.01 times the cube root of 25. So I put that in my calculator. It's 2.9. and I multiply it. 0.029, which rounds to 0.03 kilograms. All right, so you should be able to take an exponent, that is a fraction, turn it into a radical, and figure it out. You should be able to take a radical and turn it into a power that has a fractional exponent. If you have any questions, put them in the comments below.